Well, hi everyone. We're talking about partial fraction decomposition. And I've got this equation here, and it is true, and when we were working earlier in the year, we would take this and try to simplify it to this. Like if I multiplied this by x plus 2 over x plus 2 and multiplied this one by x minus 3 over x minus 3 and combined and everything, then I would get that. So the partial fraction decomposition would be starting with the x plus 7 over x squared minus x minus 6 and rewriting it as the sum of two partial fractions. Here's a partial fraction, and here is a partial fraction. Okay, now just to show that they are equivalent, now, and keep in mind, we didn't go through the steps or anything to show that this is equal to this. I'm just saying that what we're going to do is rather than start with this and get to this, we're going to start with this and rewrite this. That's our goal today. And if I were to graph this one, just look at, okay, what did I do here? Oops. Okay. All right. Got a bunch of pluses there, huh? Now, okay, it just wasn't in right. There we go. That looks kind of familiar with things we were graphing when we were graphing rational functions earlier too, doesn't it? So, and just to show that that is equivalent to that one, I'm going to turn this one on. See, the first one I had x plus 7 over x squared minus x minus 6, and it hit a bunch of pluses for some reason. That's why it was getting that syntax error. And then the second one here, if I go here and just keep hitting enter, I can change the type of graph that I have here. You can shade on either side of it. You can follow along with a marker like that. I could do that. There's the dotted line. That's the regular. I'm going to go with a heavy line there. And on your newer varieties, you can change colors on that too. So if I graph okay, I also need to make sure the equal sign is highlighted. So put it on equals and hit enter. Now when I graph, you can see that I'm just following and tracing right along that other graph. So they are equivalent. This is equal to this. And that's just so we want to start here and end here. Okay. I'm going to show just how to do that with a different example. And let's try it with this. Let's write the partial fraction decomposition of 2x squared minus x minus 1. And first of all, you make sure it's a proper fraction, which it is. I have x and over x squared here. The degree of the numerator is smaller than the degree of the denominator. So that's considered a proper rational fraction there. And the next thing, so we make sure it's proper. And then the next thing is we factor the denominator. Okay, so I'm going to factor 2x squared minus x minus 1. And you have ways of doing that. I'm going to go ahead and just use so I'm going to multiply, and 2 times negative 1 is negative 2. I'm going to add so that I get negative 1, and that's 2 times 1 is 2. It's negative 2. I'll make this one negative. So 2x squared minus 2x plus 1x minus 1. So GCF there is 2x, and that's x minus 1. Plus, and then I'll just do 1 times x minus 1 there. And so now that I have the GCF of x minus 1, and then the 2x plus 1's there. So I've got my denominator factored. So it's x plus 5 over x minus 1 times 2x plus 1. Now, I want to write it as a proper fraction. So I've got these factors here, and I have a over x minus 1, and b, because I don't know what these are yet, over 2x plus 1. Now, when I was having you guys solve these equations before, I know that we are multiplying both sides by the least common denominator, which is x minus 1 times 2x plus 1. And I would have you write that out. I want to see, just in the interest of saving a little space, if I multiply this left side of the equation by that, the x minus 1's are going to cancel. The 2x plus 1's are also going to cancel. So all that's left would be x plus 5. Now the a over x minus 1, the x minus 1's would cancel, so the a would be, that would be canceling, multiplied by 2x plus 1, and the b, the 2x plus 1's would cancel if I multiply through, b times x minus 1. So let me distribute that. X plus 5, and I've got a times 2x. I'm going to write that as 2ax plus a plus bx minus 1. Now here I want to put the, I'll write the x plus 5 again. I'm going to put the x terms together, right? 2ax plus bx plus a minus 1. And I'm going to factor out the x here. So I've got x times 2a plus b, and then I've got the plus a minus 1, just kind of grouping that together. Now this is 1x, or x times 1, plus 5. Now I want you to see this correspondence here. Here's the x times 1. Here's the x. This is an a here. Change that in your notes. 2a plus b. X times the 2a plus b. Now, this part right here is the coefficient of x here, which is 1. So I've got 2a plus b is equal to 1. And I also have a minus 1 has to equal 5. See, because the a's and b's are just constants here. But I'm wondering if you're understanding the 1 corresponds to the 2a plus b. It's what's being multiplied by x. The 5 is the constant out here, and a minus 1 is that. So essentially, we have this system to solve. And I'm going to do that right now. So a minus 1 equals 5. If I add 1, a is equal to 6. So I already know what a is. So 2a, which is 6, plus b is equal to 1. So that's 12 plus b equals 1. So I subtract 12 from both sides, and I get b is negative 11. So I've figured out a and b here. And I'm going to write the final answer now. x plus 5 over x minus 1 times 2x plus 1 is equal to a over x minus 1, which is 6, plus b, which is negative 11, over 2x plus 1. This is the partial fraction decomposition of this. You got partial fractions here equaling this. Okay, so that is how that one is done. Now, I'm going to do one more bigger one here. Actually, I'm going to just make that it for the examples for what we're going to do. All right, you guys take care.